Transform each of 55 through 58 by making the change of variable j equals I minus 1. So this is the summation from I equals 1 to n minus 1 of I divided by n minus I all squared. So this one's a little bit trickier because we have multiple letters going on here. We got I, N, and J, and we have to keep track of the structure of each of these letters. For example, I and J are index variables, but N is an arbitrary fixed constant. It is not a variable. Even though it's a letter, I think all too often we get used to calling these things variables because they're letters. But in this context, N is a fixed arbitrary constant. It could be 10, it could be 20, we don't know, but we assume that it is not a variable in the sense that it does not vary. It's fixed. Whereas I and J are index variables, and we imagine them as varying. So the first thing I'm going to do is I'm going to write a formula for J and for I. Now we already have a formula for J given to us, J equals I minus 1. But if we solve for I, by adding 1 on both sides, we get I equals J plus 1. Both of these formulas will be important when we develop this summation. Now our new index variable is J. The first thing we need to figure out is what the variable J varies from and to. Now initially, the index variable I varies from the number 1 and increments from there. When I equals 1, we can plug that into this first formula to get that J equals 0. So the first term of the summation corresponds to J equals 0 because it's the same term that corresponds to I equals 1. Now we need to figure out the upper bound of the summation. Now initially, the upper bound here is I equals n minus 1. If we want to evaluate what J is, we can plug n minus 1 into this equation to get n minus 2. Since if I equals n minus 1, we can do n minus 1 minus 1 to evaluate what J is, and that would be n minus 2. So now we need to rewrite the expression of the summation, and we need to replace all of these index variable i's with j plus 1 because j plus 1 is I, and we're using this new index variable j instead of I. We don't need to do anything with this n because this is just a fixed arbitrary constant. It is not a variable, and it is not the index variable either. So the numerator is I, which we're going to replace with j plus 1. And the denominator we're going to write as n minus I, which is j plus 1. I'm going to put this in parentheses because in general, we should put substitutions in parentheses. I should have done that in my numerator as well. However, by observation, I can see we could just drop these parentheses. But in this denominator here, it's important that we write the parentheses because we would need to distribute the subtraction to both the j and the plus 1 here. And that's my final answer. Thanks, everyone, and I'll see you in the next video.